Hi, 8th graders. Today we are going to be working on lesson 922, which focuses on the Pythagorean Theorem. And we'll get to the Pythagorean Theorem in a little while, but the first thing we need to talk about before we do that are just some vocabulary words related to right triangles. Of course, a right triangle is a triangle that has a 90-degree angle in it, and it's indicated with this little square mark in the corner where the 90-degree angle is. In a right triangle, we obviously have three sides. The two shorter sides are called legs, and the longest side, which is always the side that is diagonally across from the 90-degree angle, is called the hypotenuse. Oops, I spelled that wrong. That should be an S. Sorry. So, again, in a right triangle, the two shortest sides are called legs, and the longest side is called the hypotenuse. When we're working with right triangles, we don't always write out the words legs and hypotenuse when we're labeling the three sides. You'll find that mathematicians often use variables. So, in a right triangle, the hypotenuse, or the longest side, is usually labeled side C. And then the legs, the two shorter sides here, are sides A and B. And it doesn't matter which one you call A and which one you call B. So I'm just going to call that one A and that one B. Now, we learned in our last lesson that three lengths will form a right triangle if you square the two shorter sides and add them together, or find their sum, and that is equal to the square of the third side. So let's write that down. If we squared side A and we added it to the square of side B, in a right triangle, it's going to be equal to the square of the longest side. And that right there, A squared plus B squared equals C squared, this is the Pythagorean theorem. The hardest part of this whole lesson, I think, is spelling those words. Okay, now we're going to use the Pythagorean theorem in some example problems. So example 1 tells us to use the Pythagorean theorem, which you can see I've abbreviated it here, to find the missing side length. So we have a triangle here that is a right triangle, so I'll indicate that. And we know that we have a 3-unit side length, a 4-unit side length, and a missing side length. The side across from the right angle, the hypotenuse, is always the longest side. And as we said just a moment ago, the longest side is usually labeled side C. So I'm going to put a C there. And then the two shorter sides are A and B, and does not matter which one we call A or which one we call B, because we're going to be adding them together when we square them. So let's call this side A and this side B. Okay, we're using the Pythagorean theorem, so I'm going to write it here. A squared plus B squared equals C squared. So we need to square the two shorter sides and add them together. Let's plug in these numbers. 3, I'm going to substitute in for side A. 4, I'm going to substitute in for side B. And we do not know the length of side C, but we know we're going to be squaring it and comparing it to the sum of the other two squares. So 3 squared is 9, plus 4 squared is 16. We still do not know the length of side C. Find the sum of 9 and 16. That's 25. So we know that if we squared side C, if we multiplied whatever the length is times itself, we get 25. So what number times itself equals 25? Or you could think of it this way. What is the square root of 25? If we take the square root of each side, we find that side C is equal to 5 units. Okay, in example 2, we are asked to do the same thing to find the missing side length. And we're going to do that once again using the Pythagorean Theorem. A squared plus B squared equals C squared. Okay, so we know that the side across from the right angle is the longest side, called the hypotenuse, and that side we usually label side C. The other two sides are the two shorter sides, and they will need to be labeled A and B, and as we've said before, doesn't matter which one you call A and which one you call B. Now let's plug those values into the Pythagorean Theorem and see what we can figure out. So we're going to substitute 6 in for side A. So 6 squared plus B squared, that's our unknown side length, is equal to, we're going to substitute 10 in for C, so it's equal to 10 squared. Now let's simplify. 6 squared is 36. We cannot simplify B squared yet. And 10 squared is equal to 100. Now we are trying to figure out what B is equal to. We want to get B squared for right now by itself. So I'm going to subtract 36 from each side of my equation. 36, this cancels out, just leaving us B squared on the left side of the equation. And 100 take away 36 is 64. Okay, now we ask ourselves, what number times itself equals 64? Or, what is the square root of 64? If we take the square root of each side, we find that the length of side B is equal to 8. And our units in this problem are inches. Side B is equal to 8 inches. Okay, we need to find the missing side length in example 3. Again, we are going to use the Pythagorean Theorem here. So I'm going to get myself set up by writing the Pythagorean Theorem. A squared plus B squared equals C squared. Okay, let's figure out which sides are A, B, and C. The side across from the right angle, or the longest side, is side C, our hypotenuse. The two shorter sides are A and B, our legs. Let's call this one A and this one side B. Okay, now let's plug the values into our formula. We're going to substitute 11 in for A, so 11 squared plus B squared equals, we're going to substitute 25 in for C, 25 squared. Okay, so 11 squared is 11 times 11, or 121, plus B squared equals 25 squared, which is 625. Okay, now we need to solve for B in this equation, or get B by itself. So we're going to subtract 121 from each side, and we find that b squared is equal to, let's see, 5 take away 1 is 4, 0, 504. So what number times itself is equal to 504? Gosh, I'm not too sure about that. So I'm going to grab my calculator and I'm going to figure out what is the square root of 504. And when I do that, I get a really long decimal answer, 22.44994432, etc. I definitely don't want to use that long decimal number. So to write our answer, we are going to use estimation or rounding. The square root of 504, if we round it to the nearest tenth or the tenths place, that would be the first 4. So I go to the next number and see that, oh, it's less than 5. So I am not going to round this number up. It's going to stay 22.4. Let's see, our dimensions are centimeters for the length of side B. And let's just make that a standard practice or rule that we follow. When you get a decimal answer, let's round to the nearest tenth. Or round to the tenths place when we have a decimal answer. Example 4 asks us, would the 3 lengths form a right triangle? And they give us 3 side lengths, 6 units, 9 units, and 11 units. Okay. We know the Pythagorean Theorem now, so I'm going to write that a squared plus b squared equals c squared. So in order for them to form a right triangle, we have to square the 2 shorter sides, which we'll call A and B, and compare that to the square of the longest side, and it must be equal. The sum of the squares of the 2 shorter sides has to be equal to the sum of the longest side in order to form a right triangle. So let's plug these numbers in. I'm going to substitute 6 in for A, 9 in for B. Remember, A and B are always the 2 shortest sides, and 11 in for C. So 6 squared plus 9 squared equals 11 squared. Okay. 6 squared is 36, 9 squared is 81, and 11 squared is 121. Now if we add 36 plus 81, we get 117 for the sum of the squares of the 2 shortest sides. And for it to be a right triangle, those have to be equal. And these clearly are not equal, so no, the lengths will not form a right triangle. Okay, same question. Would the 3 lengths form a right triangle? So we're still going to call this example 4. It's just the second part of example 4. So we have lengths of 28 units, 45 units, and 53 units. We need to see if they're going to form a right triangle, which means we're going to use the Pythagorean Theorem. So let's label the 2 shortest sides A and B, the longest side C, and let's plug them in to the Pythagorean Theorem. A squared plus b squared equals c squared. 28 squared plus 45 squared equals 53 squared. Now those are squares that I certainly have not memorized, so I'm going to be grabbing my calculator and I'm going to find what is 28 squared. It is 784. Add that to 45 squared. 45 squared is equal to 2,025. And if we square the longest side, 53 squared is equal to 2,809. Now let's add these together, and then we're going to see if they are equal to our third side squared. 784 plus 2,025 is equal to 2,809. So indeed, when we square the two shortest sides and add them together, it is equal to the square of the longest side. So yes, these three lengths will form a right triangle. Alright, for our last example, I saved my favorite, which are word problems. I know that they're yours also. So in this problem, it says you leave your house and travel 13 miles west, then you travel 3 miles south. How far are you from home? With many word problems, I think it's easiest to draw a picture of our situation. So here's our home, and we've all been spending a lot of time in our homes lately. So one of the things that I do so I don't get stir crazy is go for walks. So in this problem, we're going for a particularly long walk. We are going to go out our door, and we are traveling 13 miles west. Then we change directions and we go 3 miles south. And the question is, how far are we from home? So the shortest distance to get back home would be to travel in a diagonal line back to our door. So we see here that our path forms a right triangle, and the missing length, or the distance that we are from home, is our hypotenuse, or longest side, of this triangle. So we can use the Pythagorean Theorem to figure out how far we are away from home. Let's set that up. A squared plus B squared equals C squared. Excuse me. And now we know the two shortest sides are A and B. So let's just call this side A and this side B. So we have 13 squared plus 3 squared will equal C squared. Okay. 13 times 13, or 13 squared. I'm going to scoot it over this way a little bit because I'm getting a little close to our angles. 13 squared is 169, plus 3 squared, 3 times 3 is 9, equals C squared. Okay, let's find the sum. 169 plus 9 is 178, equals C squared. Okay, we need to know what number times itself is equal to 178, or find the square root of each side. So 178 square root. Again, I get a long decimal, and we are going to follow our rule of rounding to the nearest tenth. So 13.34166, etc. If we round to the nearest tenth, that would be 13.3. So the square root of 178 is approximately 13.3, which is the length of side C. And our units here are in miles. So when we are at this point here on our walk, we are 13.3 miles from home. Okay, that was our last example problem for this lesson, 922. So you are done with your math for today. Tomorrow's assignment will be to complete review preview problems 9-74, 75, 78, and 79. I know you thought the lesson was over, but it's not. I just referred to our assignment calendar, and if you are following our calendar, lesson 922 is on Friday, and on Fridays your assignment is to watch the video and to complete the review preview problems. So today you are going to go right into completing these 4 problems following this video. If you're following our assignment calendar and you're watching this video lesson on Friday, then you should also be submitting all of your work from this week to me. Take a picture of your review preview problems and email them to me. Thanks so much, guys. Let me know if you need any help or have any questions. Just shoot me an email. Have a great day. Bye.